2.4 is adding and subtracting decimals, and decimals are not new to most of you, so just a quick reminder on this section that when you're adding or subtracting decimals, you need to remember to write the numbers vertically, and remember vertically is stacked on top of each other, and then make sure you line up the decimal points. And when we do this, what we're actually doing is we're lining up the numbers by their place value. But then once it's all lined up, you just bring that decimal point down and add or subtract like you usually would. For example 1, we're going to start with adding decimals, and we need to add 8 and 13/100ths to 2 and 76/100ths. So when we stack these vertically, this is what it looks like. So the hundredths place are right on top of each other, the tenths place are lined up, the ones places are lined up, and you can tell because those decimals are stacked on top of each other. And you go ahead and you drop that decimal straight down to here, and then you'll just go through and add like you normally do. And again, we're going to talk about how you can estimate to help with decimals too, and you can estimate before you add, or you can estimate afterwards just to check and see if you're on the right track. And we use, when we're going to round to the whole numbers place, we use this tenths place to tell us a little bit about whether we should be going up or down. So 8 and 13/100ths is still pretty close to 8 because that tenths place is less than 5, so we stay at 8. And then in 2 and 76/100ths, that 7 is bigger than 5, and so it's going to make that 2 kind of round up to about a 3. And then when we add the 8 and 3 together, we should say we should be getting something around 11. And you can see here that 10 and 89/100ths is pretty close to 11, so we're on the right track. For example B, we're still adding decimals, and this time we're adding 1 and 459 thousandths to 23 and 7/10ths. So when we add decimals, again, it doesn't, we used to say things like the bigger number had to go on top, but when it comes to decimals, it's not really about the bigger number, because we're going to equal it out anyway. It also tends a lot of times to be about the longer number. But this time we don't even really have to do that. We just have to make sure that we get things lined up by place value. So you can do it a couple ways. You can make sure that you put the decimal down first there. Or you can, if you wanted to, you could just do the lining up by place value if you know that 23 has the 3 in the ones place and that's what this one is. And then you could just stick that decimal in there where it belongs. And so you can go ahead and put that there, and then you can keep on going. It doesn't really matter as long as you do get everything lined up. That's the most important part. So this was 23 and 7/10ths. And the thing you might notice here is that we've got these blank spaces though, and most of the time in math, if you have a blank space, you can fill it with zeros. And the reason that's not going to make a difference this time if we put zeros is because after the decimal, you can put as many zeros as you want and it's not going to change the value. It might change how you read it, but it won't change the value. So we can put in the zeros here, and that's going to help us get it to be lined up by the same length at least, and we're going to add that up. After you have everything lined up correctly, you're just going to add. Again, we always add from that farthest place value to the right. This happens to be the thousandths place value, and so 9 plus 0 is 9, and 5 plus 0 is 5. 4 plus 7 is actually going to give us 11, so we're going to put the 1 here and then carry that. We're going to go ahead and place that decimal here before we jump over it so that we don't forget about it. And again, you could have done that at the beginning of the problem. That would have been fine too. But then we're just going to keep on adding. So 1 plus 1 is 2, plus 3 is 5. And then 2 doesn't have anything to get added to. So our final answer here is 25 and 159 thousandths. And again, why don't you take a second to just estimate that and see if you're on the right track. And if you rounded correctly, then you should see that 1 and 459 thousandths should still be pretty much closer to 1 because that 4 is less than 5 here. And 23 and 700 thousandths, or 7/10ths as the original problem said, has that 7 putting the 23 up to 24, and 24 plus 1 is 25, which you can see is pretty close to what we got. For example 2, we're going to be subtracting decimals, and the first thing they want us to do is to take 5 and 508 thousandths and subtract 3 and 174 thousandths. So when I write them vertically like that, I'm going to make sure that everything gets lined up according to place value, and since they both went out to the thousandths place, we didn't have to fill anything with zeros. The 0 is already part of the original number, and it matters because it changes the place value here. And then we just go ahead and subtract. And 8 minus 4 is 4, and we realize that we can't take 7 away from 0, so we go ahead and borrow from over here from the tenths place, and we bring a group over here. So 10 minus 7 is 3, and 4 minus 1 is 3, and we're going to put that decimal in there to remember to drop it straight down, and then 5 minus 3 is 2. So the answer is 2 and 334 thousandths. And again, we're going to estimate just to see if we're on the right track. When you're estimating for these, again, we're going to kind of use this tenths place, and we're just going to round to the whole number. And when we round to the whole number, this is what we're talking about, that ones place there. And so we're going to round 5 and 508ths up to approximately 6. And then we're going to round 3 and 174ths, because that 1 is going to keep the 3 the same. So we're going to round that to approximately 3. And then we're going to say 6 minus 3 is about 3. And then we're going to notice whether it's pretty close to this. And in this case, you might notice that 3 is a little bit higher than 2, but when we're rounding and estimating, it's okay if you're not exactly on. Don't change your estimate just because this number isn't more than 5. If you did correct rounding rules and used all of those techniques correctly, then you're still in the ballpark, so you're still okay. For letter B, they ask us to subtract 21 and 9 tenths and then take 1 and 605 thousandths away from that. And this one, it's going to be especially important, again, that we line up by place value. So we're going to start with 21 and 9 tenths because that's the first number. It's not really even about because it's bigger, it's because it's the first number in the subtraction problem. And we've talked about how with subtracting and dividing, you can't just switch the order around because it will change the answer. So this one has to go first. And then when we go to subtract, we're going to say minus, but we're going to make sure we put everything in the correct place value. So since this is in the ones place value, it has to go underneath the ones place value right here. And then we're going to keep that decimal where it belongs lined up. And then 605 thousandths looks like this. And just like we did with adding, if we have any blank spaces here, we're going to go ahead and fill that with zeros before we do any subtracting. And then we just subtract like we normally do. And in this case, right away, you're going to notice that you can't take 5 away from 0, and so we're going to borrow, but there's nothing to bring from over here, so we're going to go all the way over here before we can regroup, and we're going to take some away from that 9, turn it into an 8, and then we're going to bring it over here, which makes this a 10, but we have to go a little farther, so we're going to turn that into a 9 and bring that group right over here, and now we've got 10 minus 5 is 5, 9 minus 0 is 9, 8 minus 6 is 2. Make sure that decimal place gets into the right spot. 1 minus 1 is 0. And then 2 minus 0, which you didn't have to add it in there, but if you wanted to, you could. Otherwise, you can just leave it as a blank space, and we know that 2 minus 0 is 2. So this is our final answer. And just like we did before again, we're going to estimate that and just make sure that we're on the right track, that we didn't do the wrong sign or get way off lining up place values differently. This would be especially noticeable if our estimate was way off, that maybe we would have put things in the wrong place value. But this is going to tell us to go up to approximately 22, and this is going to tell us to go up to approximately 2, and when we subtract, that's approximately 20. So you can see our estimate is pretty close to our actual answer, and so chances are we lined everything up correctly. For the real-life application of example 3, it says your meal at the school cafeteria costs $3.45 and your friend's meal costs $3.90 and you pay for both meals with a $10 bill. how much change do you receive? And up until now, a lot of you are pretty used to just kind of doing one step at a time, but especially now that we're getting good with order of operations, we're going to try to write this out into one solid problem, and then if we have to do more than one step, we can go ahead and do that. So let's take a look. If you think about it, to write this out as one problem, we know how much you paid $10, and if we subtract that from the total cost, and we know it's the total cost because we're going to use parentheses so that we remember to do this step first, of how much your meal costs plus the cost of your friend's meal, and then if we take that full amount away, then that'll tell us how much change we have. So we're still going to write it out in numbers. So it was $10 paid, and I'm not really going to worry about the dollar sign here. Whoops, sorry, that was supposed to mean erasing. I'm not going to worry about the dollar sign, but I am going to write this as a decimal because the other ones are going to have decimals in them too. And we're going to keep that subtraction sign because it was already there, and we're going to keep the parentheses here, and we're going to put the cost of our meal, or your meal in the problem, which said it was $3.45, plus the cost of your friend's meal, which said it was $3.90, and we're going to close off those parentheses, and that should tell us what we're looking for here. So we're going to keep the $10 for right now because we have to do everything in parentheses first. And in this case, you might have to bump out to the side and do the side math because you have to remember to line everything up according to place value in order to add these things together. And we're adding, whoops, so I'm not quite having enough space to add it in there. I'm going to sneak in the addition sign down here. And 5 plus 0 is 5. 9 plus 4 is 13, so I'm going to put that up there. Keep my decimal in the right place. 3 plus 3 is 6, plus 1 more is 7. So the amount inside the parentheses now is $7.35. Make it look like an actual 3 there. $7.35. And then, again, we're going to have to bump some stuff up here. I'm going to just slide this up here because you're probably going to have to line these things up and do the actual subtraction. So line them up according to decimals, and so keep those decimals on top of each other and keep the place values accurate. And then we're going to have to bump way over here to do some regrouping, and we're going to have to keep regrouping until we get the 10 here. And then 10 minus 5 is 5, 9 minus 3 is 6, here's my decimal, 9 minus 7 is 2, and so what that tells us is that the final cost, or the final amount of change you get is $2.65. The final real-life application for example 4 says the Lincoln Memorial Reflecting Pool is approximately rectangular. Its width is 50 and 9/10 meters, and its length is 618 and 44 meters. And you walk the perimeter of the pool. How many meters do you walk? So when we do this, remember that perimeter of a rectangle is just going to add up all of those sides. So it's a good idea to just quickly draw a rectangle. And then if its width is 50 and 9/10 meters, then remember if it's a rectangle that both of those ends are going to be matching. And then if its length is 618 and 44 meters, oops, forgot to put meters down there, then again with rectangles these two opposite sides would be equal. So we're going to just kind of label that. And remember that for perimeter we add up all of the sides. So we're going to go ahead and add all of those sides up. And with the adding, we've talked about this before, it doesn't really matter what order you add them in, but I chose to put the two longer numbers on the top and the two shorter numbers on the bottom. And then with these, remember, they were only to the 10th place, which is right here. So we stuck zeros in there, and then we're just going to go ahead and add. 4 plus 4 is 8. Up here, you can do it in any order you want, but 4 plus 4 is 8, and then 9 plus 9 is 18. And that's going to give us a total of 26. So we've got to put the 6 there and then carry that 2. And 8 plus 2 is 10. Plus 8 is another 18. So we go ahead and put the 8 there and the 1 up here. And then you've got 1 plus 1 plus 1, which is 3, plus 5, which is 8, plus another 5, which is 13. And then put the 1 up there. And then 6 plus 6 is 12, plus one more is 13. So we do remember on this one, it's a label, or to label it with meters. And with perimeter, since we're just adding all of those labels up, we don't have to do an exponent like we do with area, because we're just adding all the meters up. So we would just say that you walk about 1,338 and 68 hundredths meters.